Hey everyone, welcome back to the channel. This is Rahul. Today we will be solving a common DSA problem, that is finding the first and last occurrence of an element in a sorted array. So in this one we can use two methods, either linear search or binary search. So as it of sorted array, it's better to use binary search method to get an efficient solution of big of log and complexity. Let's get into the problem now. So here is our problem. We have one sorted array which may contain duplicates. Okay. So if you go through this example, you can see here for this 5, there are some duplicates. So in this one, we have another input integer, which we need to find the first and last index of this number. If this number is not present, then the thing we have to do is we have to return -1. So if you check this problem, this example, you will get to know like for 5 here the position is 0, 1, 2. Starting is and the first one is second position and last one is here fifth position. This is the thing we have to do. So in this one the approach we are using is I already mentioned we are using binary search instead of linear search method since the array is sorted. Then we will implement two binary searches. One to find the first occurrence of the integer, the number. Then another one to find the last occurrence of this number. So this gives an efficient big of log and solution. So here we have one our method find with the two inputs, one array and the integer. Now I need to initialize one array list in order to store the result. So array list integer result. Okay, new array list. Then for I need two methods that I will that's like a helper functions. I will write it later. So I already mentioned one to first occurrence and the second for last occurrence. Okay, so int first equal to first occurrence of array x. So here this one finds the first index where x appears. Like this, I need the last one also. First occurrence, sorry, last occurrence array x. Now next step is we have to add both these indices first and last to our result. So simply result dot add first. Same like this we have to do for second. Means last one. Result dot add last. Okay. Now we have to return the result. Okay. Now we're done with our main method. So we have to write our helper functions as we return two functions here. First of all, I will start from the first occurrence method. Private int first occurrence int array of and int x. Sorry. Now I need to initialize some variables like the starting and the ending, like that. So int low to 0, high should be the length. Since we start from 0, we have to give -1. Then another one variable first. So that's it. Now we have to start our binary search loop in this one. So here we will use the while loop. While low, it should be continued till low less than or equal to high. Okay, we have to first of all we have to find the midpoint. So int mid is equal to low plus high minus low by 2. Okay, so by this we can find the mid value. So once we find either this mid value become our target, means the x, or it can be less than or it can be higher than, like we have three conditions. So I will use the if else if loop. If array of mid is x, then nothing, just assign first to mid and we have to move left to find first occurrence. High equal to mid minus 1. Okay, so by this we can move high to continue searching left. High to mid minus 1 means searching left pattern. Then we have to go for if array of mid less than x. Next condition. Else if array of mid less than x, then nothing, we have to increment the mid value, means we have to assign the um low value low variable to mid plus 1 to search right side. Okay, now like this we have to do for high. For high we have to move high to mid minus 1 in order to search left side. Okay, so once we're done this, nothing, we have to return first. So same like this, we have to go for last occurrence. Private int last occurrence int array index. Same like before, we have to assign three values. Int low to 0, int high to array dot length, minus 1, then last 2 minus 1. Okay. Now, like before, we have to give the condition for binary search loop while low less than or equal to high. We have to find the mid value first. High minus low by 2. So once we find, we have to check whether the mid value is x or not. If array of mid is x, then last to be mid, then we have to increment the value of low. Means we have to assign the mid plus 1 value to low, means we have to move right to find last occurrence. Else if array of mid less than x, then nothing, assign low to mid plus 1 in order to search next, then else high to mid minus 1. Now nothing, we have to return the last. So that's it. Just run it now. Yeah, it's working. So when it comes to time complexity, our this first occurrence method goes for big of log and time because binary search. Then second also same big of and log n. So both of this compute big of log n only, which is much faster than big of n. That's a linear search. Rather than going through each element, we are just dividing this array into two. By that we are searching. So it's the one efficient method. Now submit it. So as you can see, it passed everything. So that's it. Today we solved the first and last occurrence problem using binary search. So this approach ensures an optimal big of log and complexity compared to big of n of brute force. That's a linear search method. Make sure to practice similar problems to strengthen your binary search understanding. If you found this video helpful, don't forget to like, share and subscribe. See you in next video. Bye.